Section 3.4, solving equations with variables on both sides. You definitely want to have pencil and paper ready right now because you need to do all of the practice examples as well as the blue examples when you're going over your lecture tonight. And before we hop into equations with variables on both sides, I just want to give you a preview of the steps that we are going to be taking as we go through the solving process. And kind of like with multi-step equations, you're not necessarily going to be using all of these per se. For example, the step double zero and the step zero, okay? Using the distributive property and combining like terms. Sometimes that's appropriate and sometimes you don't even need to worry about that stuff. But if it is there and you need to do it, that's where you'll need to begin. The action really starts here on step one. We have variables on both sides. In other words, we have X stuff on the left and X stuff on the right. Our strategy is going to be to collect the variables, to get all of the X stuff on one side, whether it's the left side or the right side. It doesn't really matter. Typically, the strategy is going to be whatever side you put it on should be the side that creates a positive variable. That's going to save you some it's going to save you some potential mistakes down the road if you're uncomfortable working with negatives. And then once you get everything on one side, once you get all of the x's on one side, you're probably going to have a basic two-step equation. And so with the two-step equation, you'll take out the loner on that same side as the x, and then everything from there will kind of make sense for you, and you'll know what to do. All right, so let's take a look at something that has variables on both sides. It says in some equations there are variables on both sides of the equation. When this occurs, collect the variable terms on the side that would result in a positive variable. Okay, so take a look at this equation and you want to go ahead and copy this down right now on your paper. It says negative 3x plus 31 equals 6x plus 22. And believe it or not, you actually have four possibilities for how you could begin this problem. You could add 3x to both sides. You could subtract 31 from both sides. You could subtract 6x from both sides. And you could subtract 22 from both sides. And you know, you might have been taught this before. We might have even been taught differently. I'm going to ask you guys to focus on the variables. So you're going to begin with either adding 3x or subtracting 6x. I want you to collect the variables first. It kind of helps you control your own destiny. Okay, which of those two options would allow you to stay positive? Adding 3x to both sides or subtracting 6x from both sides? Well, in order to stay positive, to keep a positive variable, you would add 3x in this scenario. So you're going to add 3x to both sides. And when you do that, negative 3x and positive 3x, it's a war problem that cancels out. And so now we're just left with 31 on the left, 9x plus 22 on the right. And we kind of have one of those nice two-step equations. Well, what would you do from here? Well, we've got the couple and we've got the loner, right? So we know that we take out the loner first. So go ahead and take away 22 from both sides. You can just kind of follow along with me on this one. That cancels out, and it looks like you're left with 9 on the left equaling 9x on the right. And this is that last step where I just said, you know, you'll know what to do. You'll have a basic one-step equation. How do I destroy that couple? Well, it's glued by multiplication. That 9 is multiplying the x, so I'm going to unglue it by dividing by 9 on both sides. Creates a 1x or an x, and here we end up with 1 for x. Really important to come back up and check your answer. Okay, so if we go back to the original equation, if I plug in a 1 right here for x, I get negative 3 times 1 is negative 3, and negative 3 plus 31 is 28. So I might just kind of write that number down to get 28 on the left-hand side. Let's plug in a 1 over here for x. 6 times 1 is 6 plus 22. Look at that. It's also 28. As long as those numbers match up, that means you have a true statement. 28 does equal 28. So that means that the number I have come up with for x is the correct number. It is the only number that makes a true statement for this equation. So I solved it correctly. And those are the basic steps you are going to take. Okay, so you're going to have a lot of practice right up here up front. It's not the only thing we are doing. Feel free to go back to that example if you need to. Remember, collect the variables first and then go from there. And you want to try to keep those variables positive if possible. So you have 4 to do right now. These are the basic variety. They have a couple and a loner on each side. Go ahead and do these on your own now. Copy them down, do them on your paper. You want to hit pause, and then we'll reconvene to go over answers. Good luck with this. Okay, let's see how we did. It's really important as you're going through here to just do one step at a time. Try not to do too much at one time. That usually causes some error. So I'm going to begin with number 1, collecting variables. Am I going to subtract 9x or add 3x? My choice would be to add 3x. Let's keep things positive. It's not to say that you couldn't, excuse me. It's not to say that you couldn't subtract the 9x. You definitely could. It's just going to take you into negative land. And there's nothing wrong with negative land, but sometimes it causes error. So kind of like fractions, I don't want you to be afraid of them, but if you can avoid them sometimes, it makes your life a lot easier. All right, 12x plus 16 equals negative 32. And we're going to subtract 16. We're taking out the loner now. And I'm left with 12x equals, let's see, that you lose 32, you lose 16, you've lost 48. That's a get mugged twice. And then we're just going to divide by 12 to get our final answer. So for number 1, you should have come up with x equals negative 4. And you want to go back and plug that in and check it. If you do so, it will work out. Let's take a look at number 2. Number 2, we're going to add 4x to both sides. It's going to leave me with 4 equals 6x minus 8. Now I'm going to take out the loner. So I'm going to add 8 to both sides. And I'm left with 12 equals 6x. Now we'll divide by 6, and I get 2 equals x. And that's okay if you have the x on the right side. It does not always need to be on the left. X equals 2 or 2 equals x. Those are both equivalent statements. They're both fine. All right, number 3. Let's see, subtract 5x or subtract 4x. Well, to stay positive, I think we would take away 4x. (5x minus 4x is 1x. So x plus 13 equals 16. And we're going to take away the loner there, so minus 13. This one is not as much work because we go directly to our answer here. X equals 3. Quick check of that. 5, if I plug it back in up here, 5 times 3 is 15. 15 plus 13 is 28. If I plug it in right here, 4 times 3 is 12. 12 plus 16 is also 28. 28 equals 28, so that one works out. All right, last one, then we'll move on to something a little bit more challenging. Subtract 6x or subtract 2x. I'm going to subtract 2x. And when we do that, we get 4x plus 20 equals negative 20. Now take out the loner. So subtract 20 on both sides. Be very careful. Okay, this is testing your ability to recognize what kind of subtraction you have going on over here. Negative 20 minus 20. Is that going to be 0 or is that going to be negative 40? Well, let's get mugged twice. You lose 20, you lose 20, you've lost 40. Okay, 4x equals negative 40. We're going to divide by 4, and you should get x equals negative 10. You want to go back and plug that in and make sure that it works out, and I believe it does. Okay, so those are all the basic variety where you're beginning by collecting variables. But if you went back to those steps we talked about at the very beginning, sometimes you're going to have to deal with distributive property stuff. Sometimes you're going to have to deal with combining like terms. And so those are the type I'm going to throw at you right now. Okay. Also, your work should look like my work right now. Okay, doing one step at a time. You should have 3 to 4 lines of work for each of these. Well organized. What you do to one side, you're doing to the other. Okay, now take a look at example 2. Okay, you're going to do the same thing here, but you might have to begin by doing distributive property. And so my suggestion would be is if you start to do this and you get overwhelmed, maybe watch me do number 5 or number 6 first, and then pause it, and you can go and do number 7 and 8. But I want to believe that you guys are capable of doing this right now. So I want you to go ahead and try to work these out on your own. Remember, do distributive property first. Combine any like terms on the left side and the right side if possible, and then go ahead and start collecting your variables. Okay, so go ahead and explore this on your own, and then feel free, if you can't do it, feel free to just watch me do 1 or 2, and then at the very least get 7 and 8 done on your own. Okay, go ahead and hit pause now, and then we'll reconvene to go over answers. All right, let's take a look at how we did. And there's so much stuff going on here, I'll be surprised if I don't make a mistake. So hopefully I get through this okay. All right, let's begin with number 5. We're going to distribute that 4. So 4 times 3x gives us 12x. And positive 4 times positive 5 is going to give us positive 20. That's not so bad. Okay, and then on the other side, positive 7 times positive x is 7x. And positive 7 times positive 5 is positive 35. And so now what we've created is something that looks like, the other 4 examples that we've already done. Let's collect variables. So we've distributed. We don't have any like terms to combine. So we'll go straight to collecting variables. And I think the best strategy here is to take away 7x. It's going to get rid of x stuff on the right. And we're left with 5x plus 20. Equals 35. Now we have basic 2-step equation. Let's take out that loner. So take away the 20. And we get left with 5x equals 15. Divide by 5. Divide by 5. X equals 3. And so I'm hoping you got 3 for this answer. You can plug that back in up top. And I believe that it spits out, what does it spit out? 3 times 3, 9, 9 times 5, 14. It spits out 56 on both sides. Okay, so you'll get 56 equals 56 to kind of check that. All right, let's try number 6. Now number 6 is a little bit more complex. You got more stuff going on. Notice on the left-hand side that 2 wants to distribute right now. That x is just going to drop down and stay x. 2 times 2x is going to be positive 4x. And positive 2 times negative 4 is going to be negative 8. All of that equal to, see, positive 2 times x is 2x. Positive 2 times positive 5 is positive 10. And then we just have this 3 that's hanging out, so it's going to come join the party. All right, so we distributed first. Now, unlike number 5, we have some like terms to combine. So notice here, x and 4x can make 5x. We have 5x minus 8 on the left. And then over here, 10 and 3 can make 13. So 2x plus 13 on the right. And now we have our standard 4-term equation with variables on both sides. Is it going to make more sense to subtract the 5x or subtract the 2x? Stay in positive land and subtract the 2x. And when we do that, we end up getting 3x minus 8 equals 13. Looks like we're going to add 8 to both sides. Now I'm running out of room here, so I'm going to kind of jump over here to the side, and we get 3x equals 21. Divide by 3, divide by 3, x equals 7. So hopefully you got x equals positive 7 for your problem there in number 6. If you plug that in, it will check out. Okay, Let's go through these other ones. They're also of the complicated variety. That 5x is just going to stay 5x, so we're going to just drop him down. 4 times x is positive 4x. And then positive 4 times positive 10 is going to be positive 40. So that's what our left-hand side looks like. 7x is going to stay 7x. Positive 4 times x is going to be positive 4x. Positive 4 times positive 7 is going to be positive 28. And we have some like terms to combine. So 5x and 4x is going to make 9x plus 40. 7x plus 4x is going to make 11x plus 28. Take away 9x from both sides. It's going to keep us positive. And you'll be left with 40 equals 2x plus 28. Subtract your 28. And you get 12 equals 2x. Divide by 2, divide by 2, and you should end up with 6 equals x. Sorry, I couldn't fit that one in there. But you should feel pretty good if you're getting these right. It shows that you really understand. And we're not done with the lesson by any means. This is just kind of like warm-up, believe it or not. All right, on number 8, 2 times 4x is going to be 8x. Positive 2 times negative 8 is going to be negative 16 minus 3. Be very careful there. Make sure you're doing the right subtraction. 3 times x is going to be 3x. And positive 3 times positive 2 is going to be positive 6. Okay, let's see what happens here. I do need to combine like terms, and this is where you have to remember your type 1 subtraction rules. This is going to change into plus negative 3, so it's a get mugged twice. You lose 16, you lose 3, you've lost 19. So this is going to become 8x minus 19 equals 3x plus 6. Okay. Now what do I do? Well, I'm going to take away 8x or take away 3x. I think we should take away 3x. And we're left with 5x minus 19 equals 6. I'm going to get rid of the loner by adding 19 to both sides. And I get 5x equals 25. Divide by 5, divide by 5. And you get x equals 5. Okay, hopefully you did well on those. It's going to prepare you for what's coming next. Because not all of these equations with variables on both sides actually turn out to have a rarely understood answer. We'll have to go over some special cases. But just to review really quickly, these are the steps we just went through. Okay. Notice on the last set of 4 problems, we had to use the distributive property, and then every once in a while we had stuff left over that could be combined. So those are kind of like your pre-work steps. That's why I call them steps 00 and 0. But with variables on both sides, we always are going to start the main action by collecting those variables and trying to make sure that we have a positive x on one of the sides. So it's like you start off with x on the left, x on the right, but you're just going to end up with x on one of the sides. And then steps 2 and 3, you're following the basic process for basic 2-step equations, something you should already be familiar with. Okay, not every problem is going to turn out to be like those examples we just worked through. So let's take a look at some special cases. Here it says, in some equations where there are variables on both sides, the variables might get canceled completely. Okay, so every once in a while, variables might cancel completely. That means you're going to lose your x's, and you're just going to be left with numbers. When this occurs, check to see if the resulting equation is a true statement. Okay, if it is, all real numbers will work and is the solution. So, after the variables cancel, if you get a true statement, okay, and what I mean by true statement is something like 5 equals 5, 2 equals 2, 0 equals 0, 20 equals 20, something like that, okay? If you get a true statement, then your answer is all real numbers. That means you could plug in any number you want for x and it would actually work, Okay, so let's take a look at what's going on here. This is one type of problem. If you were to try to solve this, you'd begin with your distributive property, right? So 4 times x is 4x. Go ahead and do this one with me. Have out your pencil and paper and go ahead and go through this one with me. 4 times negative 5 is negative 20. And you also get 4x minus 20 on the other side. And that just looks kind of weird. 4x minus 20 equals 4x minus 20. It's kind of like the same thing equals the same thing, right? All right, well, let's not think about it too much right now. Let's just kind of keep going through the process. What would we do next? Well, we would collect variables, and we would do that by subtracting 4x. What happens when we take away 4x from both sides? Well, variables get canceled here. They also get canceled over here. And we are left with negative 20 equals negative 20. So once the x stuff disappears, you're going to have to look at this statement and make sense of it. Negative 20 equals negative 20. Is that true or is that false? Okay. This one happens to be true. So we're going to say true, therefore, that's the symbolic language for therefore. True, therefore, the answer is all real numbers. Okay, or we could say x equals all real numbers. You could plug in any number you want for x in the original and it will work. Go ahead and try it. Pick some numbers, plug them in for x on both sides in that original equation. It's going to come out to a true statement each time. Okay? Now this has a special name and you need to know the name. Okay? The name is identity. When you get one thing on the left equal to the exact same thing on the right, we call that an identity. So negative 20 equals negative 20 is an identity because negative 20 is negative 20. It's like saying 5 is the same as 5, or Mike equals Mike, or Javier equals Javier. It's an identity. It's the same thing. You equal yourself. Okay, so that's what an identity is. Identity, in this case, will be x equals all real numbers. Okay, so your answer, what you'll write, is all real numbers. But I want you to know that it's also called an identity. And that's one possibility. When variables get canceled out, you could end up with a true statement. All right, so what happens if you end up with a false statement, right? So this is going to be an example of that. So variables might cancel completely. When this occurs, check to see if the resulting equation is a true statement. Okay, if it is not, okay, so if not true, okay, there is no solution. So a false statement is going to imply that there's not an answer. Let's go through the math on this one. What would you do first? Well, you'd collect variables. You'd take away 3x, and you'd get negative 9 equals 10. Notice variables have canceled out completely. You're left with this statement. Now, is it a true statement or a false statement? This is a false statement. And if you get a false statement, that means that there is no solution. You could not come up with any number for x that's going to make this equation up here on top true. Okay? You cannot come up for any you can try if you want. Whatever you plug in for x, it's just not going to work. And that's what that false statement implies. So just remember, when you're doing these equations with variables on both sides, sometimes variables will cancel out. It could mean that you have all real numbers as a solution, or it could mean that you have no solution at all. And then you could also just have a normal answer, right? So they could be like examples 1 through 8 that we already did before, where you end up with x equals a number. Okay, last thing I want to mention before you have final practice. Don't get confused between no solution and having a solution of 0. If you end up with something that says x equals 0, that means you have a solution. 0 is a number, it counts. Okay? No solution is only going to pop up when variables cancel out. Okay, so if you were to solve this guy, 5 times x is 5x, 5 times positive 2, positive 10, equals 4x plus 10. Notice that's not quite an identity. When we go to collect variables, we'd take away 4x from both sides, and variables don't cancel out. So, and that's the norm. Normally variables won't cancel out, and if they don't, then you're going to end up with some kind of solution. Here we have x plus 10 equals 10. I'm going to subtract 10 from both sides, and I get x equals 0. And that's just the number answer that I get. Okay, so just like I got x equals 2, x equals 6, x equals 7 in some of the previous problems, this just means that x equals the number 0. It's very different from no solution. Okay, you plug in 0 up top, it will work. Okay, let's see how well you've paid attention. Now, this is the final test, and I'm going to give you some hints here. Okay, one of your answers is going to be a fraction. One of your answers is going to be 0. One of your answers is going to be no solution, and one of your answers is going to be all real numbers. So I'll say that one more time. One of these is a fraction, one of these is all real numbers, one of these is no solution, one of these is 0. And so you'll kind of know you're right if that's what you come up with. So good luck. Go ahead and copy these down, take your time, and then when you're done and you're ready, we'll reconvene to go back over answers. All right, let's see how you did. On number 9, we're going to distribute that negative 1/2. Okay, so a negative times a negative is a positive, and 1/2 of 6x is 3x. So this is going to be positive 3x. Negative 1/2 times positive 10. Now that's a negative times a positive, so we're going to get a negative, and half of 10 is 5. So that's just a fancy way of saying 3x minus 5. And then on the right side, we also have 3x minus 5. Okay, we're going to collect variables. Let's go ahead and take away 3x from both sides. And you'll notice that this is one of those deals where the x's cancel out completely. We are left with negative 5 equals negative 5. And so when x's cancel out completely, it's a true-false dichotomy. So is that a true statement or a false statement? Well, this one is true. Therefore, x is what? All real numbers. You can plug in any real number and it will work. And also remember that that's called an identity. Okay, very good. Hopefully you got that one right. All real numbers. Let's move on to number 10 and see what happens over here. It looks like I have some stuff to distribute on the right. The left-hand side going to stay the same. So 8x plus 7 equals 2 times 4x is 8x. Positive 2 times positive 6 is positive 12. And then that positive 8 just comes along for the ride. Okay, I'm going to combine like terms over here. So rewrite 8x plus 7 equals 8x plus 20. And then go ahead and collect variables. Take away 8x, and you can see that this is another one of those funky ones. X's cancel completely, and you're left with 7 equals 20. So we're testing the veracity of that statement. Is it true or is it false? This one is false. And what does false imply? It's false, therefore no solution. Okay, so you could not find any values to plug in for x that are going to make a true statement. So hopefully you're 2 for 2 with numbers 9 and 10. Let's see what happens with number 11. I've got some distributing to do on the left-hand side. So 6 times x is 6x. 6 times positive 3 is positive 18. 4 is going to come along for the ride. 2 times x is positive 2x. Positive 2 times positive 7 is positive 14. Okay, so I've got like terms here and here, and I need to combine those. So 6x plus 18 equals 2x plus 18. Now what I do? Well, I got to collect variables. I can either subtract 6x or subtract 2x. Subtracting 2x is going to keep me in positive land. So that's what I'm going to opt to do. And here I get 4x plus 18 equals 18. Okay. Now I'm going to take out the loaner. I subtract that 18. Let's see what happens here. Those cancel out. You're left with 4x on the left. These also cancel out, so what are you left with? Well, you're left with 0. Okay? Keep going. You divide by 4 on both sides, and when you do that, you get x equals 0 over 4. And what number is that? Well, 0 over 4 is just another way of saying 0. So this is your problem where x equals 0. You go back and plug in a 0 up there, it's going to work out. All right, last one. This one must be the fraction we were talking about. We would add 7x to both sides to collect variables. If you do that, you're going to get 12x minus 9 equals 11. You would add 9 to both sides, taking out the loaner. And you end up getting 12x equals 20. And then we'll have to divide by 12. And that's x equals 20 over 12. Well, that can be reduced, right? So if I divide both top and bottom by 4, I should get x equals 5 over 3. So 5/3 would be your answer. That one's a little bit harder to check, but you could plug it in and do it. It would work out. All right, how'd you do? Hopefully pretty well. This skill is huge. You're going to need it next year a lot in geometry, and you'll need it for the rest of the chapter. So hopefully you got all these right. If not, I took the time to explain every problem. That way you can go back through the ones you need a little bit more slowly. Okay, good job. Good luck on your assignment.